Hello everyone, I am Rajini. I am currently pursuing my BTech first year in CSC branch at SRIT. Today I am going to present a small video on Cauchy mean value theorem and its applications. Cauchy mean value theorem states that if a function is continuous on closed interval a comma b, and the second condition is if the function f of x is differentiable on open interval a comma b, then c belongs to a comma b such that f dash of c is equals to f of b minus f of a by b minus a. This is the classical Cauchy mean value theorem statement. Why do we need Cauchy mean value theorem? Sometimes we need to compare two functions, not just one. For example, to compare the ratio of two functions, limits involving derivatives, and L'Hospital rule foundations. Cauchy mean value theorem statement. Let f of x and g of x be two functions that satisfies both f and g are continuous on the closed interval a comma b. And the second condition is both f and g are differentiable on open interval a comma b. The third condition is g dash of x is not equals to 0 for all x belongs to a comma b. Then there exists at least one point c in a comma b such that f dash of c by g dash of c is equals to f of b minus f of a by g of b minus g of a. The geometric meaning of Cauchy mean value theorem. The theorem says there is some point c where the ratio of their slopes, which means tangents, equal the ratio of the overall changes from 2. Geometrically, at the tangent line to f of x and the tangent line to g of x are proportionally parallel, which means their slopes have a constant ratio. This means the instantaneous change between the curves at point C matches their average change over the interval. In simple terms, we can say that both curves grow at the same proportional rate at some point inside the interval. Relation to classical MVT and Cauchy mean value theorem. Cauchy mean value theorem is the general form of the classical mean value theorem, which is the MVT. The classical MVT is a special case of Cauchy mean value theorem obtained by choosing when we have. So Cauchy mean value theorem becomes f dash of c is equals to f of b minus f of a by b minus a. Thus, every application of mean value theorem is included inside Cauchy mean value theorem. Cauchy mean value theorem deals with ratios of changes between two functions, while classical mean value theorem deals with change of one function with respect to x. In summary, Cauchy mean value theorem is the general theorem and mean value theorem is the special case derived from Cauchy mean value theorem. Example for Cauchy mean value theorem is let f of x is equals to x by g of x is equals to x plus 1. The conditions for Cauchy mean value theorem is first step is checking conditions. Both the functions are continuous on closed interval 1 comma 3 and both the functions are differentiable on open interval 1 comma 3. If the conditions are satisfied, then go to the step 2. The step 2 is apply Cauchy mean value theorem formula. According to Cauchy mean value theorem, there exists such that f dash of c by g dash of c is equals to f of 3 minus f of 1 by g of 3 minus g of 1. And then compute the values. F dash of x is equals to 2x and g dash of x is equals to 1. F of 3 minus f of 1 value is 8. G of 3 minus g of 1 value is 2. Then f dash of c by 1 is equals to 8 by 2. The final answer is 4. And then the condition 2c is equals to 4. The final answer for c is 2. There exists a point c is equals to 2 in the interval 1 comma 3 such that Cauchy mean value theorem holds in this problem. Important application for Cauchy mean value theorem is how Cauchy mean value theorem gives L'Hospital's rules. Cauchy mean value theorem tells us that for any near there exists some point between and such that f of x minus f of a by g of x minus g of a is equals to f dash of c by g dash of c. If it is 0 by 0 form, this becomes f of x by g of x is equals to f dash of c by g dash of c. As the point also approaches, therefore limit x tends to a by, and then f of x by g of x is equals to limit c tends to a f dash of c by g dash of c. And the other applications of Cauchy mean value theorem is L'Hospital's rule proof. CMVT is the foundation for deriving L'Hospital's rule for limits of type and the generalization of mean value theorem. Cauchy mean value theorem is a special case of Cauchy mean value theorem. And then comparing growth rates. It helps compare how fast two functions increase or decrease using the ratio and deriving inequalities. It is used to prove many calculus inequalities by relating two functions through their derivatives. And error and approximation analysis, Cauchy mean value theorem applied. It is useful in estimating how errors in one function are related to errors in another, especially in numerical methods. And the conditions for Cauchy mean value theorem is, first condition is f of x and g of x must be continuous on the closed interval a comma b. And the second one is f of x and g of x must be differentiable on the open interval a comma b. Third one is g dash of x is not equals to 0. For every point in a comma b, denominator must not become 0. Both functions must be defined for all values between a and d. Graphical illustration of Cauchy mean value theorem. Here is the graphical illustration of the Cauchy mean value theorem. The plot shows two functions and a point inside where Cauchy mean value theorem applies. The tangent lines to both curves are showing that f dash of c by g dash of c is equals to f of 3 minus f of 1 by g of 3 minus g of 1. Here is the graphical illustration of Cauchy mean value theorem. Here f of x is equals to x square, g of x is equals to x plus 1, and the tangent to f at c is 2 and the tangent to g at c is 2. Advantages of Cauchy mean value theorem. It generalizes mean value theorem to two functions and it is used to prove L'Hospital's rule. It compares growth rates of two functions. It helps in error estimation. It is useful in proving inequalities. Disadvantages of Cauchy mean value theorem is strict conditions required, which means continuity plus differentiability plus no zero denominator. It is not easy to apply compared to simple mean value theorem. Geometric meaning is less initiative. It fails if the second function's derivative becomes 0. Limited practical use compared to standard mean value theorem in basic problems. Applications of Cauchy mean value theorem. It is applied in the derivation of L'Hospital's rule. It is applied in comparing growth rates of two functions. For example, in sin x versus x. It is applied in proving inequalities in calculus and trigonometry. It is applied in the error estimation in approximations. It is applied in finding relations between two function derivatives in advanced analysis. And the final conclusion for Cauchy mean value theorem is, Cauchy mean value theorem is a stronger and more general form of the mean value theorem. It connects the rate of change of two functions on the same interval. It is essential for deriving L'Hospital's rule. It helps in comparing growth and proving inequalities. Despite strict conditions, it is a key tool in advanced calculus. And thank you for hearing this video.